last video I went ahead and talked about the imaginary unit. I went ahead and took a look at what that video looked like on the computer and saw that it was a little bit pixelated. I apologize, this camera's about 7 years old, so God, 2005. Anyways, I'm gonna go ahead and just try and compensate for the poor video quality by just writing a little bit bigger. And I'm not going to spend much more time talking about my crappy camera. Alright, so I'm going to go ahead and just jump right into it. Talked about the imaginary unit. I hope my video was good enough so that I can start jumping into the arithmetic. And let's go into it. Let's go ahead and say I had the complex number 2 plus, let's write this a little bit bigger, so 2 plus 3i, and if you remember, complex numbers basically just thinking of this all as one. Okay, so let's go ahead and add to that 2 plus 3i, 6. So 2 plus 3i plus 6. Well, nothing really deep happens here. I color coded it for a reason because you know already that I'm just going to add the 2 and the 6 to get 8 plus, forgot my black, plus 3i. And that's basically how you add complex numbers. Well, what if I did, instead of plus 6, I did minus, and actually let's make this a minus, and this, yeah, let's keep that a minus. What if I wanted to add another complex number, 2 plus 3i minus, and I'm going to think of this as a whole complex number, I don't know, 2i, there, just spit out a number. Well, what you do here is you got to distribute the negative, so this is like saying, what was a negative? So I'm going to distribute the negative by making this a negative 6, and this a positive 2i. So I can go ahead and drop all the parentheses actually, and I can even drop that negative on the negative 6. It was a green negative. Oh my god, I keep erasing part of my numbers. And you can collect like terms, so 2, 6, so it would be 2 minus 6 plus 3i plus 2i, and 2 minus 6 is just negative 4. Ooh. Let's try and do things properly. Negative 4, and then 3i plus 2i is just 5i. So that whole problem, you can see the addition is fairly straightforward, and addition and subtraction likewise will be as straightforward as addition was. Now let's go ahead and just jump right to the multiplication, which is a little bit interesting. And I'm going to go ahead and rewrite the definition of I. I is simply equal to the square root of negative 1. Alternatively, you could write this as I squared being equal to negative 1. I didn't say this last video because I assume that some people might know this, or that most people would know this, but just in the off chance that you don't, and it's okay if you don't know this, if I have, well, let me not even use an imaginary number. If I have the square root of 2, and let's say, oh gosh, I'm trying to do this algebraically. let's say x is equal to the square root of 2 for some reason. Okay, well, in algebra, when you want to get rid of a square root, you know, like if you wanted to add one to both sides, if you wanted to add one to both sides, or if you wanted to add one to one side, you'd have to add it to the other. So, like if I wanted to add 1 to square root of 2, I'd have to add 1 to x in order for this to still be valid. What I have to do to one side, I have to do to the other. So to get rid of the square root, if I really wanted to, I could just multiply, or excuse me, I could square this side, which is like saying the square root of 2 times the square root of 2. But I'd also have to, but again, I'm squaring this side. I'd also have to square this side too. So a square root, and this is something some people learn this in calculus, but the square root of 2 is the same as saying 2 to the half power. Half power. I'm sure a lot of people already know that. Half power ain't coming out, right? So that's like saying 2 to the half power. Well, if I squared both sides, I guess in effect what I'm doing, I'll do the square to this side, is I am multiplying, and just imagine we're focusing just on the exponent right here. I would be multiplying this 1/2 times 2 if I squared both sides. So, you know, 1/2 times 2 is just equal to, well, you can even do that, 2 over 2. You multiply across like that. And 2 over 2 is just equal to 1. So, basically what happens is the square root disappears. And I just wanted to go ahead and explain that real quick. Hopefully I explained it decently enough. If you just got confused by that, I apologize. I don't mean to confuse anybody. But anyways, let's jump right into the multiplication of complex numbers. Ooh, I know why I did that. Let's just jump right into it. I'm not going to even color code stuff this time, so I'm going to put these things down. Alright, so what if I did, what if I wanted to multiply, I lied, I will color code, 3 plus 4i times, gosh, I don't know, 2 minus 2i. Well, you remember back in algebra about this thing called, or this technique called FOIL, where you just basically do the first, you multiply the first, the outer, then the inner, and then the last. It's how you would multiply, oh god, I forget what they call factors. They call these factors. It's how you multiply factors. The rules don't change whenever you're multiplying complex numbers. You do the FOIL technique as well. So we'll go ahead and multiply this out. 3 times 2, and I'm not going to even do, oh, why the hell not? 3 times 2 will just equal 6. 3 times negative 2i, well, that's going to equal negative 6i. No, 4i times 2, I almost forgot where I was going with that. 4i times 2 is going to equal 8i. And if I seem a little bit absent-minded in this video, it's because I'm dead tired and I just can't sleep, so I'm doing these videos for fun, I guess. Negative 4 times, 4 times negative 2i is going to equal, well, here's something interesting. Negative 4 times 2, negative 2, 4 times negative 2i. So let's just go ahead and write this. 4i times negative 2i. Well, let's go ahead and separate everything actually, because 4i is just like writing 4 times I times negative 2 times I and well, what happens here? Well, 4 times negative 2, that's going to equal negative 8. I times I is just going to equal negative 1. Negative 8 times negative 1 is just going to be 8. So all of that is just going to equal 8. And I wrote it in green because it's a real number and not an imaginary number. Okay, so, oops, forgot to do the equal sign. Let's just go ahead and collect like terms. 6 plus 8 is equal to, pen's dying, 14. Negative 6 plus 8, well, that's like saying 8 minus 6. Negative 6i plus 8i is like saying 8i minus 6i, and that's just going to equal 2i, so 14 plus 2i. Okay, so that pretty much covers the arithmetic. Multiplication, subtraction, and addition. I'm going to go ahead and for the next video, which was what everything I've done so far has really led up to, how do you divide by a complex number? How you divide a complex number by a complex number, and maybe I'll even do a real number divided by a complex number. Because I'm doing homework a lot right now these days, and I have my math lab, and my math lab's a computer program, and you basically are assigned homework questions, and you got to go into this website and input your answers into there. And there was this whole incident where I put in the right answer, but I didn't put it in the correct format, whatever that even means. And the My Math Lab website said my answer was incorrect, even though it was correct. Anyways, I posted it on Facebook. Fred saw it, and he was just confused as to how it resulted. And I was like, well, why not? I don't got much to do tonight. I gotta go to school tomorrow, so I ain't going out. Why not just do this and just show him how it's done? And I'm killing time, basically. Alright, so let's go ahead and show you how to do that next video.